Yo, what's up guys? Welcome back to another video. Today, I want to create a library called the TaskRipper. And essentially what it's going to do is it's going to simplify the process for creating many tasks and running them in parallel, and also balancing the work between all of the threads. Alright, so over here, I have kind of a rough outline of what we're going to be doing in this video. Now this video is going to be part of the Code With Me series where we literally program on the spot. This is a project I just thought in my head and I said, hey, it's probably not too difficult to do. Let's at least give it a try, and I want to start this series off with something pretty interesting. So let's see how we're going to kind of design this. So I have an idea for some sort of contract. For example, we're going to have a property called action, which is going to be the actual action we're executing end time. We're going to have an iterations property, which is going to be how many times we're performing this action. We're going to have a description of what the action is. We're going to have a start and end time for the action. And we're going to have some sort of dependency called iExecutionEnvironment. And it's going to have a single property called thread count. We're going to have some sort of action result, which has the contract and execution environment as properties as well, so we can inspect where our result is coming from. So it's going to make more sense once we start programming. All right, guys, so here is kind of how the usage is going to look like that I envision. You're going to create some sort of contract and you're going to fill the parameters that it requires, like the description and the actual function you'll pass in. And then you're going to call an execute method on some sort of an executor. Right now it's called action executor. I haven't got that far ahead. I'm envisioning it to be static. You don't need really an instance. You really just need a contract. That's the most important thing. And a result. So once you call it, you get the action result. So here's result. Again, we're going to support asynchronous operations because that makes a lot of sense for us, right? But we're also going to support synchronous. I'm going to focus mostly on asynchronous this video. I think it's more interesting. So now that we got an idea of what the usage looks like, let's start coding this thing. Okay, so let's start with the iExecution environment. It's going to have a single property called thread count. Now the action contract is going to have a reference to an environment. Now, of course, we need some sort of action here, so the actual action to execute. And we're going to have the iterations. Right now, everything is a get, as you can see. So the kind of point of doing this is to make these properties read-only. In other words, we're making the whole interface, the whole object, hopefully, we're conveying to the user like these should be immutable. So we don't want to be able to change the contract once it's created. These properties by themselves can belong in another interface. Now, same thing with iDateRanged. We can condense the properties in here. Now, instead of keep adding it to a contract, I actually want to create another interface which represents parameters. And right now that's going to implement these two. So we're going to modify iActionContract. It's going to extend iWorker parameters. Now there's one more thing. There are different types of actions. This is an action that has no parameters and no return value. So it's not really that useful. We need to do something different. We're going to create an interface called iActionable, and this is going to house our action. So right now we have a basic infrastructure for how we're setting up our dependencies for this project. We didn't implement anything yet. We're going to have some default implementations, but the idea of this library is, hey, you get to create your own implementations as well. So now this is much more useful. iActionable of T has a parameter. Now, similarly to iActionable, we need an iFunctionable, and it's essentially going to use a function. All right, I went ahead and moved iterations to its own interface. And I used iExecutionEnvironment as part of the contract. All right, so at this point, we can create one more interface. So an iWorker result for the simplest part is going to have some sort of action contract at minimum. Now this contract also has the iExecutionEnvironment. So you can figure out pretty much everything from the result, what was executed, because you have the whole contract available too. All right, so in the worker result, we also want to display a time span for the duration of the result, how long it took. We're also going to have a property called threads used. All right, so now we're going to implement the action contract. Now, I'm not going to lie to you guys, I'm not totally satisfied with how we have the worker result. You see, for every action contract, there's a specified implementation. So for example, for action contract, it implements iActionable, and iAction contract has one parameter and then two. So that means for our results, we have to have multiple types of contracts. And also our action contract implementation, it's going to have an implementation for each one. So hopefully I come up with a solution later in this video, but if I don't, that's fine. We could leave it for next video. And you know, if you guys have suggestions in the comments, that also works. So again, we're going to implement iAction contract, and we're going to implement the interface like so. We're going to create a constructor. So that was actually a miscite. All right, so now when we implement it, we should have a property just like that. All right, so I went ahead and created a couple of throw clauses. These are essentially null checks. If description is null, it's going to throw that corresponding exception. So this is going to ensure this contract is valid. We also want an interface that has settings. So execution settings. So we're going to replace execution environment with execution settings. And I'll explain that right here. All right, so now that we have an action contract and potentially some settings along with it, we can add or remove as we wish right now. But for now, we'll just keep it like that. So an iAction executor, again, we're going to have two versions, async and regular. So let's go ahead and create that. So cancellation token here is extremely important. This task, whatever it is, can run for a very long time. There needs to be a way to cancel that. So we want to support cancellation token, as you know, .NET supports cancellation token, and it's pretty useful as is. So let's try to implement one of these. We're going to start with the iAction executor async. So now we have our private internal function, internal function. So the first thing we're going to check if action contract is null. If it is, we can't really continue. So here's our current issue. We need to figure out how to balance the number of iterations that the action contract has. So if we go ahead and look at the implementation, we need to answer this question and we need to put it behind some function. So we need to kind of return the number of threads and how many iterations there are per thread. So let's see, let's create that dictionary. Iterations by thread equals new dictionary int. Yep, there we go. So how are we going to do this? Let's create a different example. 100 plus remainder, which is 110. All right, so let's try to figure this out. Index divisor minus 1. Okay, that is more readable. And then index plus plus. So iterations by thread. We want to add index. Now, we specifically took one off here because I want to do that at the end. So we're going to do tuple dot quotient plus remainder. So that should be the end. New work balancer dot balance. And we're going to pass in the parameters here, dot thread count for now. So what we're going to do is create the task. So tasks.add. All right, so this part's important. So we need to create a new task. Now, what we pass in here is extremely important. So in this case, our action contract right now, it has access to the action. We might actually change that, but for now, we're gonna pass an action. Now, remember, we have a cancellation token here. We do want to pass that in. And task creation options, we're gonna specify that it's long running by default. All right, so now we have our tasks. Now I want to call another function like execute tasks. So this is going to return a task itself. So if we take a look, represents a task that represents the completion of all the supply tasks. So when all of these tasks are done, return that task. So we currently implemented a single action executor. Unfortunately, I really don't want to create so many results and all of that. So we got to find a better solution. The best thing I could come up with is removing it from the contract and then just passing in the action as part of the execute methods. And so now, since these look identical, if we take a look at iFunction contract and iAction contract, they're actually identical. So we don't even need to specify if it's an action or not. We can just call it iWork contract, rename it, and get rid of the function contract. So not used anymore, not necessary. Now if we go back to the iAction executor, we can have overloads for all of the types of actions. At this point, we might as well just use the action directly. So we don't even need to specify the contravariance. So here's the iAction executor, and again, we could do the same here. So I'm thinking maybe for the next video, we're gonna, instead of having the interface require all types of actions, we're gonna create extension methods that actually do that for us. Let's take a look at how it works. We first create an action contract. We need to pass in the iExecution settings, so I mocked one up right here by newing up a new action execution settings, which requires an execution environment. If we take a look at that implementation, all we're doing is implementing the thread count property by referring to the environment.processor count. As well as to instantiating the execution settings, we add a description of test, and the number of iterations is 1010 like our previous example. Action executor async creates a new work balancer. Right now it's not static. I know we talked about it before, but right now it's a new instance. We could talk about that or change it next video. Anyways, we call executor.execute async by passing in the action contract, the action by calling get action here. Basically, we're generating ones and zeros from this random class. And in .NET 6, it looks like, or maybe .NET 5, we have the shared thread safe random instance. So that's pretty awesome. I always used to have trouble with random, so this is a huge plus. So we run one test and we basically check the threads used should be equal to the execution environment.thread count. That's one of the things that we test. So we're going to go ahead and run it and let's see if it works. As you can see, it did run before, but let's see if it still runs. And it ran successfully. If we go ahead and debug, we can see exactly what's going on. I'm going to step over some of the trivial things and we can inspect that after. Here's our executor, which has a work balancer instance, and our action contract, which looks like this, which has its execution settings with the execution environment set to 1. Here we have async internal. If we go ahead and take a look again, thread count is 1. And in here, we call the work balancer. Our dividend is 1010, divisor is 8, it's our number of threads. Divide remainder equals number of threads. We add our instances. So once we're at this point, we could see that 126 for each plus 128 for the last thread. Remember, in this example though, my actual machine has 8 logical threads. If we go ahead and take a look in performance here, I have 8 logical processors. We get the tasks, which should be 8, and they're all executed with that get action method. And execute test at the moment is only going to execute them once because we didn't implement the actual iterations logic. We're going to do that in the next video. So anyways, we just check if the threads used is equal to the environment.thread count, which is 8. Now, if you might be wondering why during the runtime this was 1 and then it turned into 8, I think it's because the property was not computed yet. To be honest, I'm not entirely sure why that was the case, but it did end up getting the correct value that I expected, which is 8. Anyways, guys, thank you so much for watching. Please leave any feedback at all. I know this was kind of cut up really quick in succession, and there wasn't a lot of breathing room, but let me know what you guys think, and I'm happy to all criticism. I just want to improve and kind of make great videos for you guys at the end of the day. So if you like this type of content, let me know by smashing that thumbs up button. And I never thought I'd say that, but hey, I did. All right, guys, thank you so much for watching again. Leave a like, subscribe, and leave a comment below about what you think about the video. Appreciate everything, appreciate y'all, and I'll see you in another video. Take care, everyone. Peace.